Hey guys, how's it going? What's up? So it appears that NASA can't stop a little tiny asteroid. It's only 500 meters in size. I don't know how they guesstimate the weight of this thing, but I think they're way out, but you never know. I mean, they don't even know what kind of material this rock is made out of. They're going on the assumption of it's just an asteroid. It's probably just made out of the same stuff as all the other stuff. Not necessarily, okay? So they're guesstimating stuff, which, I mean, there's some plus or minus stuff they're willing to admit to here. You know, there could be some differences of it could be a little sooner that it reaches us, or it could be a little bit later. It's variable. So they have some omission there. They're not putting a dead science to this, which is actually smart for a change. But anyways, they're thinking that this thing's got about 1,200 megatons of energy, which is 80,000 times the energy of the Hiroshima bomb. And you know, people are still suffering from that one even today. You know, that happened a long time ago, right? So we got enough problems dealing with our ocean right now from Fukushima's problem, you know, which is still ongoing. But anyways, so this rock is about 500 meters in diameter, or 5 football fields, right? And weighs about 79 billion kilograms. That's a lot of weight, okay? Making it over 1,664 times as heavy as the Titanic was. Wow, that's crazy ass, isn't it? Well, anyways, this leaves only dangerous nuclear option, which is not preferred, as it could result in Earth being showered with radioactive rock fragments. Well, you know what? I think if you were going to blow this sucker up when it's, you know, maybe a few thousand kilometers from the Earth, we might have that problem. But right now, this thing is like millions upon millions of freaking miles away right now. So, and I would really question any kind of authenticity of this even coming out of NASA. And we'll get to that. But right now, some chick who, well, maybe it's a guy, I don't know, Christian Howley, I'd have to look that person up. Don't know if it's a chick or a guy. But anyways, the chance of an impact appears slim now, but the consequences would be dire. Well, if it hit, sure, right? The study aims to help us shorten the response timeline when we do see a clear and present danger, so we can have more options to deflect it. The ultimate goal is to be ready to protect life on Earth. I'm all for protecting life on Earth. I agree with that, okay? But the thing is they're guessing its trajectory. They have no idea the actual trajectory of this thing. No clue whatsoever. Right now, they're looking at something that, in the farthest distance away that it is currently, that thing is the size of a human hair, you know, when you think about looking at it. And they've magnified this thing millions of times in order to get a close enough view at it to even guesstimate the time frame. Now, we all know when it comes to a car, if you do 60 miles an hour, that's 1 mile per minute. Okay? And your car has to be, your engine has to go at a specific RPM with tires on your car that are, everything's calibrated to be as dead bang on as it can get. And there's always plus or minus a little bit, even with GPS tracking. I know I track every car I've ever owned with a GPS. I rely on my GPS speedometer more than I do my car speedometer, because I know that speedometers in cars are out, and yet so are GPSs. But there's kind of a pretty good consistency there that it's plus or minus a couple kilometers an hour. So, you know, if I feel like speeding, for example, okay, I'll rely on my GPS, because at least if I do get busted, you know, I can say, well, look, this is what my GPS says, right? Because the tires that are on my car right now, if I want to do 100 kilometers an hour, I actually have to have my speedometer in my car reading about 110 almost, right? Because of the different size, and those tires weren't calibrated for my car for the computer. You know, it's just a pain in the ass to reprogram every time. So I rely on the GPS so that I'm at least doing 100 kilometers an hour, even though my car says I'm going faster. So that's a pretty big discrepancy if you start thinking about it when you're tracking the RPM of a vehicle too, or in this case the RPM of an asteroid. Their tracking system would have to be somewhat of a laser track that can actually touch this item, in my opinion. It would have to actually touch the item. The laser beam would have to touch the item in order to track its actual RPM, and you'd have to have other tracking set up too to be able to track its miles per hour, okay, in order to calculate time, right? Because you have to have RPM, you have to have your speed in there as well in order to figure out your time. So they have to have this technology, which I guess we do because, their best guesstimation here is, whether it hits us or passes by us, it's approximately the year 2135, which is 117 years away. Now, granted, we're all going to be dead by then anyways. Anybody currently alive on the planet right this second is going to be dead in the year 2135. Now, showing some concern at this point would be a good idea because you never know what's going to come out of the woodwork around our solar system anyway. So I see no problem in prepping, for making something bigger, because what they originally built was this 9-meter tall craft that weighs 8.8 tons to deflect asteroids from the Earth and destroy them with nukes. I mean, you're talking a 9-meter tall item. I mean, it's got to have some pretty massive diameter on it, which means the nukes that are on there for payload would have to be at least the size for height as the craft is. When you think about it, in order to carry the warheads that would have to be launchable. Unless, of course, they're putting off little firecrackers, in which case I can see why their little hammer project ain't gonna work. Now, think of it this way: they spent probably billions of dollars in research and development to make the hammer, which at the time they thought was suitable to do something, but apparently it can't handle a 500-meter rock. Well, of course it can't. It can't even handle a 200-meter rock, because if you think about a firecracker, put a firecracker on the table, light it off, what happens? You might get a little tiny burn mark. Put the same firecracker into a closed-off box, what happens? The box goes boom, kind of like a grenade, right? So, that actually made sense in that one movie. Can't remember the name of it off the top of my head, where they had to drill holes into the rock, into this massive, massive asteroid that was like miles in size, right? And they had to launch nukes in there to try and split it in half, and in hopes that both fragments would miss the Earth, because otherwise, the way things were going, yep, we would have all been destroyed, right? According to the movie. So you'd really, to be realistic about it, even a huge nuke, it wouldn't destroy this thing, but it would certainly be able to shove it off course if you hit it in the right spot, which means you got to do what? You got to hit it sideways. You can't hit it dead on. You got to hit it sideways, right? Now, even if you're off the side a bit, that's not a bad thing. You still get a sideways shot at it and you can shove it off, but you have to know its exact precise trajectory, which means it needs to be a lot closer to us than it is now, so that we don't have to also magnify it so much. Because right now we're magnifying a human hair diameter to something that they guesstimate as 500 meters in size. And they have no real idea how big this thing is. It could be way smaller, it could be way bigger, who knows. Their RPM, the more they magnify it, the more it throws off the RPM gauge too, right? Which means their speed calculations are out, which means their time frame for how many years it's going to take to get to us is way out, right? So they're actually doing stuff way too soon without even realizing it. Because basically what happens here is the asteroid hits the bullet. If you ever shoot guns, and I've shot guns a lot, you got a bullet going at a little tiny bullseye, okay? Because if you bring that target up to you, I used to shoot 6x6 targets, and that bullseye was not even the size of a dime. It was about maybe 2 to 3 times smaller than a dime, okay? And I had to get that bullseye, right? So I had to be dead bang on, no inconsistencies whatsoever, and I'm going to smack that sucker right in the middle. Even a side impact, slight side impact, off the bullseye. But you have to be, right on that edge to clip it, right? So this thing would have to be right on the edge of the landmass of our planet to just clip it to do any kind of destructiveness. Okay? That's a huge calculation. That's something that, I'm sorry, at the distance it's away right now, and based upon whatever information they haven't given us, that's crazy, So it's kind of there's a lot of stuff in here that doesn't make sense, because right now they say we can reach this thing in 7.4 years. Now, with our current craft available to us to get to Mars takes 300 days. Now that's only when Mars is at its closest point to the Earth in alignment, because for us to get anywhere in our solar system to other planets, it's all based on the alignment that we can judge how much time it's going to take and how much fuel we're going to burn. Now you're talking about 7.4 years for a craft that they say we can get to this thing at. It's going to take 7.4 years. That is a hell of a pile of fuel to burn. Okay? Even with the best technology we have, the best engines we have on the planet right now for spacecrafts, that is a lot of fuel, which means that's going to be a really big craft. Okay? So, likely it's going to be a much bigger craft than this asteroid is. Okay? Because it's got to go through 7.4 years of constantly burning fuel to get onto a collision course with this sucker. Why not just bitch slap it with the craft? Why waste nukes? We've got to build the craft big enough to hold enough fuel. Even if the craft is half the size of this football field, which, it would be much bigger regardless, we just slam into the sucker. But we got to slam into it on its side. We got to hit its side, not in the middle. If you hit in the middle, all you're going to do is really slow it down. You're not really going to knock it off trajectory. But you hit it on the side impact, right? And you got to be pretty close to that edge to do it, because what you've got to do is you've got to take a forward RPM spin and you got to knock it off its axis, okay? And put it into a side forward spin. Now, depending on which side forward spin you want to accomplish here, which side of the Earth is this thing presently going to be coming at it from? So we have to hit the opposing side that right now is the furthest point away, right? So we got to smack that on the opposite to push it even further away. That's what I'm saying, okay? So if it's on our left side, we got to hit it on the right and shove it more to the left. Okay, easier explanation, right? And then we could accomplish it 100% guaranteed. It's going to miss us. Maybe. Because even though we course correct it, it doesn't mean that some other asteroid, that's small, isn't going to smack into it and put it back on course. You don't know what's going to happen in the universe. There's so much error that could happen. It's just insane. But hopefully nothing does. And so if we do smack this thing the right way, we're definitely at a danger. Because right now it's a 1 in 2,700 chance. So, that's still one. That's still one chance. It could still sideswipe us at least. Because it's not coming as a dead bullseye, right? It's definitely not as a dead bullseye. Not that I can tell anyways. But anyway, so I think there's a lot of discrepancies in here. But I think this is another way, too, for them to release new technologies and have us accept it without question. Kind of like back in the 80s when they said, technology is about to smack by leaps and bounds in medical fields, science fields, technology fields, so our toys like our computers, cell phones, and so on. And what happened? Exactly that. Did we all accept it without question? Of course we did. Because we're mindless little sheep that just believe what we're told. Everything we're told, we believe it, right? So Not that that can always be a bad thing. Sometimes it's a good thing, but, you know. But in this case, I think there's kind of another thing like that going on because, you know, when you think about if Mars is at its closest point and it takes us 300 days to get there at X amount of speed in our present craft, they've got to be hiding something on this planet. Something's got to be hiding, okay, that is far superior than anything we got right now to go into Mars in 300 days. And they want to make it to this thing and say they can make it to this thing in 7.4 years presently, okay? So that means that this technology or of a craft has been on the planet for better than a decade or more, okay? Likely more, okay? And it's been well hidden enough, but now they kind of got to let the cat out of the bag, I guess, and then they say they're going to use it for this and that, and who knows what they're going to use it for. But it's also going to be a very large craft, too. It'd have to be a very large craft in order to do it. And if they're still going to shoot nukes at it, right, then they're going to have room to fit an awful lot of big nukes up there because they're going to have to piss pound this rock a few good times because right now all they're doing is throwing off firecrackers to knock it off its trajectory. Okay? Because like I said, they're still guessing that it's only 500 meters. This thing could be the size of the damn Earth for all we know because the further you get away from something, the smaller it gets. The closer, the bigger. Okay? Take a look at the moon sometime. At its closest point, okay, that it comes to us. That's pretty big, and that thing's like 250,000 miles away from us, right? So, or is it kilometers? I'm not quite sure. But anyways, it's 250,000 of kilometers or miles from us. And so if the moon was right beside us, oh, it would be huge, wouldn't it? Would it be bigger than us? Quite probable, you know, when you think about it. Because like I said, the further you get away from an object, the smaller it gets. So if you take a planet like Jupiter, which is massive, massive, and you compare it to the Earth, we're just like a little speck to Jupiter, right? Okay? But the closer we get to Jupiter, the bigger we get to Jupiter. So if Jupiter was looking at us, okay, we would get bigger as we get closer, but we get really super tiny the further away we get, right? And we always follow these different orbits where we come closer and further away from planets all the time and to the sun, right? So, which kind of makes sense for all of our seasonal changes. And right now in Canada, it's cold as hell. Okay, I want winter gone. I want summer back. Give us 45 degrees, I'll be happy. But anyways, and I've always hated the summer, but the last few years I've been loving it. Because the winter's, oh, man. The older you get, the more you're cold. You know, that's the weird thing about it. But take a good look at this, though, and use some logic behind it, some sense. But I think there's a lot of discrepancies in here that can easily be pulled apart. I mean, I've pulled them apart pretty simple. But and this little tiny fart craft they got, well, I don't know. That's kind of stupid to waste millions of dollars for something that can't even deflect a 500-meter object. I mean, come on, really? You know, you could have done a better job, you know, but they didn't. And so they spent millions of dollars on a toy that is absolutely useless, you know, which, you know, comes to mind when you think about it. Shouldn't they have tested this thing on something at least? You know, to see if it would do anything. And if we're really smart geniuses on this planet, those little geniuses that came up with the creation of this little 9-meter deflectable toy would have known that it couldn't handle something of the size of Bennu, or whatever you want to call this thing, that's only 500 meters in size. Because let's face it, 5 football fields, it's not very big. Okay, when you really think about it, it is not very big. So, yeah. Anyways, judge for yourselves. Let me know what you guys think of this. I think there's way too much crap here. But it's kind of nice that if any of this is even remotely related to NASA, well, at least they had enough balls to say, we can't deal with it at present time, right? But we can get to it in 7.4 years, even though it's 117 years away from us. And like I said, go back to the calculations. You know, how far away is this thing? I mean, the slower something goes, the longer it takes to get somewhere. I agree there. And we are traveling at a very fast rate of speed in order to make it there in 7.4 years. You know, which means if we have a craft that can make it to this thing, why can't we go faster to Mars? Why can't we go to other planets in our galaxy, you know, in a reasonable amount of time? You know what I mean? Anyways, judge for yourselves. Let me know what you think. We'll catch you on the next one.